All right, welcome back. This is the UPTIME podcast. This is episode 9. I'm your co-host, Dan Blewett. I'm joined here remotely by lightning expert Alan Hall. Alan, how are you?
Hey, Dan, how are you? Crazy week this week, huh?
Yeah, man, we were busy, and DC's extended their lockdown till June 8th, so like longest in the world. But
till when?
But yeah, a lot going on.
Whoa. Till when?
June 8th.
June 8th. Oh my gosh. Yeah, we're going to be out of lockdown next week. It's sort of county by county a little bit, but I doubt that we're going to. Washington, D.C. is unique because it's its own entity, right?
I guess so. And someone was asking me, they're like, well, D.C. doesn't have a governor. Is it
right?
Like, does the mayor have the power to do that? And I assume so. I don't really know. Of course, it seems like all the governors are getting sued and losing anyway. So it's like, I don't even know what's happening in our country. It's like, okay, no one has the power to do anything. So here we go.
Let's
I don't know.
Right? Yeah, no, I think I was telling you earlier, listening to CNN is making me nuts. It's just constant new normal. Well, when has society been in normal? I don't know when that is. And reporters talking about new normal, it seems to me, is just from an engineering, and this is an engineering perspective on all this. There is no normal because every day we're trying to make the world a little bit better, or it's changing in some way or another. And there is no normal. So tomorrow is different than today, as it was different than 10 years ago. So what, right?
Yeah, I mean, I get that, but this is definitely some sort of new normal. Like, I have to wear a mask to go in an elevator. Like, that's not normal to use that term.
Well,
I get that.
Yeah, okay. So have you ever been on an airplane where people smoked?
No.
All right.
That's true. Yeah.
Right? You ever been in an office where people smoked?
No.
I was. Right? You ever use a rotary telephone, like with the actual dial, you had to spin the damn thing?
I'm a millennial. You know that I haven't.
No.
I grew up on Instagram. Actually, I didn't grow up on Instagram.
On TikTok.
I'm much past all that. Yeah.
Right.
No,
okay.
I never. Yeah.
Yeah. So,
all right. Fair enough.
Right.
Fair point.
Right. I mean, I was in Seattle on September 11th. Things changed that day. We had a new normal that day. I had plastic silverware on my flight back, which I never had before. That was a new normal. Yeah, every day is a new day, and humans adapt. If we haven't adapted to the changing environment, then we have been gone a long time ago. We're not dodo birds. We're able to think through some things and work through the situation we're in right now, and we will work through it, and we'll get back to some sort of quote unquote normalcy, whatever that was. Great.
Yeah.
Right. I think we're okay.
Yeah, I'm just suffering from coronavirus talking about it fatigue. Yep. Like. It's like literally the only thing anyone can talk about. It's like becoming very obvious that it's so front of mind for everybody.
Yeah.
Like very, very front of mind.
Yep.
It's crazy. But so speaking of which, as I transition us out of coronavirus forever,
yes.
On the docket today, we're going to talk about wind turbines, which is a pretty interesting thing. Obviously, not all the circuitry, but the towers,
right?
And potentially blades. We're going to talk a little bit about leading edge erosion, and some of these newer wind turbines on flatland have a direct drive mechanism, which is interesting.
Right.
So, and we're going to talk a little bit about a TED Talk. Let's start with this TED Talk. So, I was watching this TED Talk. I should know the guy's name, but I forgot it just now. But he talked about renewable energy for the future and what this looks like. Is it realistic that we can have so much of our energy, like essentially save our planet? And his, I think, main premise is that, A, we're killing birds and bats. Solar needs so much land to be sustainable because the electricity... the conversion rate of solar into actual usable electricity is still very low, that we have to basically just decimate tons and tons of land to do this, which is obviously bad for the environment. And then like natural features, like using a hydraulic, using a dam as like a hydraulic, is it a pump? Am I describing that right? Like you need certain features for that even to work.
Right.
So even some of these good ideas like that aren't feasible depending on where the natural land features. So where do you fall on this whole thing? Do you feel like that's valid, that we don't have a chance in this, or what?
Well, we've been using hydropower since the 1920s. Niagara Falls was one of those first hydro dam situations, and I think there was a competition there between Edison and Westinghouse and Tesla won. And they've been creating power from that ever since. So we've been in some sort of renewable energy systems since really the dawn of electricity. The question is demand, and be able to satisfy demand, and to satisfy demand in a clean fashion. Solar, obviously, we can't have all solar. We're never going to be 100% solar. We're never going to be 100% wind. We're never going to be 100% oil or gas or hydro or even nuclear. That won't happen because in the United States, we tend to think of everything like the United States, like every country is exactly like us. That's not the case. We don't have a lot of earthquakes. We don't have a lot of obviously don't have typhoons. And certain parts of the country are pretty stable in the United States. But there are applications where solar makes complete sense. There are applications where wind makes a lot of sense. And with the new advancements that Elon Musk is talking about on the Tesla battery side, then some of the solar wind applications even begin to get more realizable because you can store energy with them. Same thing for nuclear, right? So nuclear has advanced a whole bunch. And in your lifetime, in my lifetime, Dan, nuclear has gone from being, in the safety record is actually very good, but
it's deceptive.
It's deceptive.
People have this big emotional response to it because they think of the horrors of Chernobyl and 3 Mile Island, and
the possibilities of how bad it could be. And 3 Mile Island in the United States is the one that everybody remembers here, and Chernobyl over in Russia, Soviet Union, but we've made a lot of advancements since then, and the next generation of nuclear is going to be safer, more efficient, and be able to do things we couldn't do 30, 40 years ago. That's the evolution of society. So we need to constantly be looking towards the future and seeing what we can do now that we couldn't do in the past, and see how that fits in with everything else we're doing. There's room for nuclear. There will be, and I think you're going to see a lot of action, at least in the United States, and to try out some of these new systems. It's going to take, when you develop a nuclear facility, it's going to take, obviously there's a lot of regulations involved there, and then just building the site. So you're talking about a 5 to 10 year process to get something sited. It's a little bit different than a wind turbine. But
and that was his ranging point, was that nuclear needs to come back, and that's our most sustainable option, and that solar and wind just really aren't. But I also feel like he jumped to conclusions. Kind of making this quick leap from we've killed a lot of bats, therefore this is never gonna work, or we need more solar. Like it takes so much land to get solar power, therefore this is never gonna work. Well, solar is gonna get more efficient too. You won't need the same amount of space in 10 years that you do today to get the same amount of electricity, obviously. But
that's right.
Percentages will still maybe be a fraction of what they need to be to really be sustainable without, harvesting so much of, the desert or whatever. Because there's still it's a busy ecosystem, even though it's maybe not as inhabitable as, we humans would like.
Right. I think of it this way. Having more choices at the cafeteria of energy sources is better. So then we can make educated decisions for the places that we are at. And having more ideas and more things thought through and more things tried is only going to be better for society long term. And we can't eliminate them. We can't eliminate them haphazardly, which is what we've done a lot of times. Solar's off the table. No, it's not off the table. Come on.
Yeah.
Right. If there's anything we have learned, particularly with Elon Musk and Tesla and all the things that are going on there, is things we thought were off the table are now back on the table in a huge way. That's why, because Musk never took them off the table to begin with. He just said we just need to make some improvements to them and see what we can do with it. Everything's on the table. It's got to be on the table.
Yeah, and battery technology seems like it's improving a lot. And I was reading and watching some videos about what is it called? It's where you have your electrolyte and it's a flow battery. And they're talking about flow batteries being one of these up and coming, large scale storage potentials for energy. So
and that Elon Musk,
there's a lot of people on it.
There's supposed to be. There's more. I think Musk tweeted something not long ago about some battery breakthrough that he's talking about. It sounds like it's consortium with some companies over in China, but all the details haven't been released. But the conjecture is that the cost of energy storage is going to go way down. and it made me reach that magic threshold where it's now worth it to invest in it. We'll see, but it's just like me. I'll give you a good example on my end. I've had a battery powered lawnmower since 1995 or 6. I haven't had a gas. I never owned a gas mower. Okay, why? Well,
Weird. Yeah.
Well, okay. So I'm an electrical engineer, so I understand sort of the motor thing and how the batteries work and all that. But I never have to change oil in it. I never have to put gas in the thing. It always starts. I'm never changing spark plugs. I'm never worried about oil leaking in my garage. I never worried about it on a cold day not starting. I don't have to fix a carburetor and retune carburetors all the time. I have had put zero maintenance in a mower in 25 years or so. Every time I got out there, it started. Now, that's an application for renewable energy. It's a battery-powered lawnmower. It's got a little charger on it. It is the most simple device. And when we learn from those simple devices, then we get to the next stage, like maybe a car, right? So we go from lawnmowers to cars to airplanes, which is probably where we're going. But each of those steps has been an advancement, and I'm not sure society has always grabbed onto the fact that there's a convenience to having a solar wind farm, or there's a convenience to having a nuclear power plant, and we need to kind of wrap our heads around that and start making decisions, not necessarily based on emotion, but based on what the reality of the situation is here, what we would prefer, but what exists, and then make that decision, an educated decision on that. I'm not sure we're always making that from an engineering standpoint. We're sort of making emotional decisions about our energy sources, not making the mathematical, how do we improve society the most. And the way we improve society the most, as we're finding out, is when people become electrified and civilizations become electrified, a lot of health improvements, food improvement, the whole society starts to improve. So there's a trade-off. There's a trade-off. I mean, we've been making that trade-off for 100 years, and we're going to continue to make it.
Yeah, and that's an interesting point. How do you have a mower that's 25 years old? Like, what kind of battery technology did they even have back then?
Lead acid. Like a car battery. They actually were motorcycle batteries is what they were. They're motorcycle batteries. Yeah.
Have you replaced it? How that seems shocking to me that something like that has lasted that long.
Well, I actually replaced it recently. In the last about 3 years ago, I replaced my original lead acid Ryobi battery powered lawnmower with a basically the Home Depot brand of lawnmower, electric battery powered lawnmower has a lithium ion battery in it. So it's a huge step up. I know this sounds weird to talk about, but my lead acid battery mower would go about 45 minutes, which you can do a lot of mowing in 45 minutes. With that lithium ion, and my lithium ion battery is now self-propelled. First off, my old one wasn't. So it has more power capability and it runs longer. So in that 25-year period, I went from lead acid push to self-propelled and running longer. Yeah, and I just saw at of all places, Home Depot, where they have a battery-powered lawnmower, riding lawnmower. So we've gone from push mower to self-propelled to now battery-powered riding lawnmower, which is it's huge, right? Because the one thing you want to get rid of is the little 2-cycle blowers and all those things. Those things are burning oil all the time. It's good to get rid of those things and go to something that's a lot cleaner. Electricity is a lot cleaner, particularly if nuclear power is the energy source, or solar or wind are the power sources for recharging those batteries.
Yeah, is yours is it like a plug-in battery, like the little family of power tools, or is it built in?
No, yeah, it comes out. So it's about the size of a...
So you could have a couple others, and just if you run out, you could just throw a new battery in and keep going?
Which is what we do. I have a couple, I have 2 batteries, but that whole set, if you go to Home Depot ought to sponsor this podcast.
Yeah, we're not... Yeah. Today's episode is sponsored by Home Depot, which is actually, I think we talked about this, but Menards, if you're in the Midwest, Menards is just, it's such a great home improvement store.
And my parents love it.
It's so much better than Lowe's and Home Depot. I won't get into it, but Menards close to my heart. Anyway.
Yes, no, it's totally true. My parents have a Menards back home, and they rarely go to a Home Depot unless they're forced to. But
the difference is when you're there's a lot of times to buy the expensive tool, like the good tool that you're going to keep for a while, and then there's a lot of times when that's just not the case. Like, you just need a cheap, quick tool, and you're not going to use it again, or it doesn't matter if it doesn't last very long.
Yep.
And you don't get good options like that at Home Depot. Like, there's lots of times where you're like, I just need these 3 little things, and you're like, and you leave and you spent $35, and you're like, this sucked. Like, this shouldn't have cost this much. Like, and then you go to Menards, you can get those same things for like $9 total.
Yeah.
And they have like a good generic section and overall their prices seem to be a lot more reasonable. And I don't know, their model just seems to be very different than Home Depot.
Oh, it's
way
interesting.
Different. Well, a lot more helpful people too.
Oh, at Menards, yeah. Well,
yeah.
On the East Coast, what I think is close to Menards is Tractor Supply. You ever have a Tractor Supply?
Yeah, they're out there. Mm-hmm.
All right.
Of course, it's way smaller though. But yeah,
they tend to be way smaller. They didn't used to be way smaller. They used to be big in the Midwest, and now they have sort of smaller stores. I like Tractor Supply because they have all kinds of tools and hardware, and it's not super expensive. And there's somebody there who's actually used a tool in their life, so they have somebody who can actually help you find what you need. That's a different place. So I buy all my hardware from Tractor Supply. Engineering tip of the day: go to Tractor Supply. Yeah,
and it does vary. Like, I think Lowe's is my bottom. It's a cleaner store than like Home Depot. It's like more polished, but and you find those old jobbers who are very helpful at all of them, but they seem to be more sparse in Home Depot and Lowe's. But anyway, so you've been, I mean, in our other podcast, Struck, like, we're going to be talking about electric airplanes soon, so this shouldn't be surprising that we can do an electric lawnmower. I mean, we can't. If we're going to put things up in the air with people in it, then we should get lawnmower done first.
Lawnmower first, and then weed whacker, lawnmower, and then go-kart, riding a lawnmower, and Tesla, and then go from there. Yes.
Well, and that would be a boon for like the I mowed lawns for a little lawn care company. My godparents, their son, he's like 10 years older than me, but I worked for him for a summer in his little lawn care company, and just thinking about at how many of his those professional mowers that are $6,000, $7,000, $8,000 that are really powerful, you wonder if you can get to the point where we can, again, if we can do an aircraft, you could do one of those lawnmowers, but you're talking about how much money and gas that would save him, and oil, and just maintenance and upkeep. To your earlier point about not having to change spark plugs.
Yep.
That would seem like a really big deal for the lawn care industry, not to mention how much grass we're cutting in America. Like, if all of our lawnmowers became electric, that would probably be a really big deal for the planet.
In the United States, it would be a big deal, just because even the blowers. The guys you see blowing the leaves and blowing the grass after they cut the grass, although the little 2-cycle powered blowers, it's a huge deal. I mean, if we're talking about trying to be greener, then great. It doesn't have to always be the biggest thing you see. Getting society to change their opinions about electric things starts at the consumer level. And then it works, and it works from there, right? If a kid growing up today only knows a battery-powered mower, then when they get to a battery-powered car, it's a lot more, they're familiar with it, right? It took us a long time to get to a gas-powered car and to figure out how to make those things work, and then the transition over is just as tough, right? So it starts as a generational thing. It really is.
Yeah.
You got to think of it like that.
Of course, it takes the least amount of energy is horses. So if we just go back, we just get back on horses again, then we'll be in good shape. I mean, we just overthought this whole thing. Let's just go back to horses and oxen, and then we'll be all set.
Yeah.
So wood wind turbines. I'm looking at this tower here. So it says standing nearly 100 feet tall, and this is an article on Bloomberg that we'll link in the show notes. Yep. But 100 feet tall on the rocky shore of the island Björkö in southwest Sweden. So it looks like a normal wind turbine outside. Obviously, it's painted and everything, but inside, it's a composite wood made of 3 to 4 millimeter thick layers of Nordic-grown spruce, covered in a waterproof coating, and they say it's as sturdy as steel posts. So,
maybe.
Alan, what do you think about this? So this is an interesting idea because we talked about in a previous episode that there's just a graveyard of huge fiberglass wind turbine blades, and this is talking about the tower,
right?
Not the blades, but there's a lot of waste. So how what do you got on this?
Yeah. Okay. Let's just back up a minute. So one of the most recyclable materials on the planet is steel. just because you can cut it and reform it into something else and remelt it again. So wind turbine towers are made out of steel typically. I'm not sure what the benefit of this is besides obviously the energy it takes to heat the steel up and to process the steel. It's typically a coal power thing to recycle it. But you have a similar situation with wood. Someone's got to go out and cut this tree down. It's got to haul it to the lumber mill. It's got to be processed by the lumber mill. It's got to be made into some sort of shape, and then it's got to get hauled to the site, and that's going to get screwed on, nailed on, whatever they're doing to make this tower.
Yeah.
So I understand using the renewable resource thing. That all makes sense to me. I'm not sure if wood is the right answer. And so that's just the recycling part of that picture and the energy usage. But the other half of this is on the electrical side. The electrical engineer in me says, I don't have any shielding on my power wires and my control wires that are running up and down this tower, because wood provides zero shielding from noise from lightning effects or anything else for that matter. So how are lightning currents getting from the blade all the way down to the earth? And am I coupling a lot more energy into the wiring system? I have to be coupling more energy into the wiring system. So am I actually having to put more work into this thing because the tower is now made out of something that's non-conductive? That's my first worry. It's like, man, I don't know. I mean, the early wind turbines were, if you think of the nacelles, the little covers that go over the generators, those were made out of just fiberglass. So electrically, they were transparent. So any sort of electrical noise from the outside world just passes right through that, gets into our electronics and our wiring and our systems. And testing we used to do years ago on wind turbines found that like those fiberglass shells are just really bad at protecting electronics, right? There's not providing any shielding. So we measure these huge voltages and currents on wiring inside the nacelle during simulated lightning strikes, to the point where equipment was dying all the time because of it. And to take shielding away just adds additional work. So you got to put shielding back in, and the tower was like an easy shield.
So what are we shielding from? So you mentioned noise. Back up. Explain this to me as if I'm 12. What are we shielding from? What does this mean? What is the noise? Like, how is that going to affect the systems?
All right, let's take a simplistic lightning case. Lightning strikes a blade, and that current's going to run down the blade. It's going to run through the nacelle, and then it's got to go run down through the tower to get to Earth. Well, if the tower itself is made out of something that's non-conductive, then you have to create a wire path. So somewhere they've got a wire connected. It's
like another down conductor.
Right.
Yeah.
There's a down conductor in the tower. So that down conductor is carrying a lot of energy. All this lightning energy is going down this one wire. Well, all your power wire, all your phase wires that are from the generator spinning and pushing power out to the outside world, those wires are getting the energy coupled from that grounding wire. So the down conductor is coupling energy on those other wires sitting right next to it, upsetting the generator system. So you've got this bad coupling going on that the levels can get really, really high really quick. Yeah.
Gotcha. Interesting. Yeah, I didn't think about that. So the other thing that is tossed around a little bit, but it doesn't seem like in any serious like commercial way, is wind turbine blades. And what do you feel like the engineering? I mean, does engineering of this work?
Well, blades even modern blades today have a lot of balsa wood inside of them. Instead, and on an aircraft part, we would use honeycomb core, which is a paper product that provides stiffness to a piece of composite structure. And on wind turbine blades, you use balsa as that core, so there is wood inside of most of the blades today. That's normal. And on smaller wind turbines, like the homebrew wind turbines, they've been made out of wood for a long time. It wasn't until recently you started making out of fiberglass and carbon fiber. So there were a lot of wind turbine blades around homes, particularly around the Midwest, that were made out of wood. Obviously, they have not much or zero lightning protection on them, so when they did get hit, they just exploded. Yeah. So wood is not a great conductor. It's like lightning hitting a tree. It's pretty much a bomb. You got shrapnel all over the place.
So does that seem like it's easier to repair or more difficult to repair if it takes a lightning strike and has some damage compared to a fiberglass blade?
Well, a wood blade's going to have a lot more collateral damage. If it depends on where the lightning goes. If it goes inside, wood is just going to explode like a tree. Fiberglass has some design strength to it. It tends to crack. Both are bad.
Yeah.
Nothing here is
Gotcha.
easy, right? Welcome to engineering. Nothing is easy.
Yeah, fair enough. Well, and to put the wood thing to bed, it says the main, like you said, recyclability. I think you're spot on with the recyclability. Like steel is always like, okay, this thing's done. All right, let's melt that tower down and make it into something else. Like, yeah, steel's always, it's never really going away, which is kind of I remember as a kid, my mom was like, hey, turn that off. You're wasting water. I'm like, this water's not going anywhere. It's not going down the drain and then like leaving the planet. Like this water's going to the
It's gonna
this
rain.
whole idea of waste. Yeah, this whole idea of wasting water. Like water never leaves. It's funny. It's wasting money. It's wasting money.
Yes.
But
Yeah. It's wasting money. In Maryland, though, you're right next to the ocean, and it's always raining there, and there's always a plethora of lakes of fresh bodies of water there.
Mm-hmm.
But in Arizona, in California, it kind of matters, right? Because it doesn't rain as much. Yeah, so
Yeah,
I
that's true.
got the same thing in Nebraska, but they have underground aquifers in Nebraska that are sizes of states. So they're not going to run out of water anytime soon there. But I get the same lecture, sure.
yeah, of course. But anyway, so I digress. But yeah, so it seems like it's not the recyclability thing that they're pushing. It's really the. It says that a single full-size wooden turbine would avoid the 2,000 tons of carbon emissions produced by making a steel analog. So that seems to be the appeal, I guess, as Siemens Gamesa has pledged to be zero net emissions in the coming years. So they just don't want the processing damage to the environment, just putting out all that carbon, that CO2. So
Yeah, but
interesting. I don't know that much about that side of things. I hear all this like carbon neutral stuff, and I haven't delved into the research about it, so I'm not really sure where I fall on that.
well,
Like you said, if that's
yeah, and Dan, you gotta weigh both sides of the equation. It isn't like the wood side has zero net effect. There's a net effect on
True.
that side too, and don't let the marketing people sway you over just because it's made out of trees, therefore it's better. There's still a lot of energy being
they got to
used.
truck it over here too. Yeah, they
Right.
got to cut it down. They
Yep.
got to use chainsaws with gas in them. And
Right.
It was the same thing about like the ethanol, like the E85.
Yeah.
They talked about that for so long, like, oh, this is our solution to gas, but it's like, well, you have to process all this corn, like these combines are like, there's so much processing where, and I don't know the numbers here either, but people are like, after subsidies and all this other stuff, like E85 is not really that great, or ethanol is not really that great compared to gas because it still has to be trucked around and all this other stuff. It's interesting debate hearing both sides of it. Yeah.
Well, hey, I will tell you, there's in my mind there are two competing technologies that are the realistic way forward. One is maybe we get to some sort of battery power thing that makes sense, and we can actually store some energy in it, and we get to some sort of nuclear thing. The other part is hydrogen. I, for the life of me, cannot figure out why we don't have hydrogen-powered cars, because those cars were developed probably that was 2001ish, 2002ish. Honda had a hydrogen-powered car. I think you can actually still get hydrogen-powered cars from Honda, and maybe even General Motors. It just burns. It makes water.
They emit water.
They emit water, right? And it uses roughly the same infrastructure we have today. That you go to a refueling station, you'd plug your nozzle into the car. It would take 2 minutes, 5 minutes to fill your tank up, and away you go for another 300, 400 miles on a tank of hydrogen. Why haven't we done that? I do not know, because it isn't like battery-powered cars are the safest thing in the world either. Think about it. One of the first things they had to do when the battery-powered cars started coming around again, and this is probably the third or fourth time in my lifetime that we've had battery-powered cars, is you got to train all the fire stations and all the EMS people how to deal with a battery-powered car, because it's full of energy, right? And the first thing that you worry about is that thing's going to have some sort of electrical short and catch on fire, which they do, right? So there's a lot of infrastructure things with battery cars that you have to straighten out just with any sort of change in technology. Why didn't we do hydrogen? I do not know. I don't know.
Yeah, that's a good question, and it's also like I was big into the aftermarket Jeep world when I was in high school and early into college, and I worked on old cars with my brother. And there's this one thing that a lot of for some reason it's big in like the off-roading world where you have like a rock crawler or something like that, you're going to be off the grid for a while. People will convert them into propane. I know they have propane running buses in a lot of cities.
It's true.
And it's interesting because it's usually cheaper, at least it was back. I'm not sure if it's still cheaper for the equivalent amount of propane, but your oil just like stays golden apparently forever because of how clean the propane burns.
Oh, could be, yeah.
Which is really fascinating. But yeah, just and that's not really a very difficult switch over. And I think it was more efficient, but I can't remember. That was probably 10 years ago when I was thinking about all that. It's like, I'll put a propane tank in my Jeep. It's like, nah. But still, it's still out there. That's probably not a reasonable solution because it's still a fossil fuel. But,
right.
Maybe not.
But again, we're talking about transitions, right? You need to get from a 2-cycle engine to a 4-cycle engine, from a 4-cycle engine to some sort of battery-powered thing or something that has less emissions, and you're going to transition to where you want to get to. It just doesn't happen immediately.
And so going back to battery, in this article here, it says Tesla's preparing this media day to kind of announce that it sounds like the battery is going to lower the expected cost per kilowatt hour to under $100, which they say is like a big milestone where that's going to make electric cars a lot more affordable. So that was supposed to happen or I guess it's coming up soon, but no firm date set. So pretty interesting. I was listening to his podcast and he mentioned just some of their speed advancements, like their car. We talked about this going 0 to 60 in 1.9 and then this new battery technology. So it does sound like they're doing a lot of interesting things. And they're trying to eliminate cobalt from these batteries because that's like kind of like a blood diamond kind of situation over there. Just brutal conditions for workers and
conflict mineral.
It's a conflict mineral. Yeah. So, well, last thing on the docket today, I want to talk a little bit about leading edge erosion. We'll talk more about this in coming episodes, but that's one of the main issues with maintenance for these wind turbine blades. Tell me a little bit about leading edge erosion and protection for these leading edges, because obviously these blades are moving so fast, and especially in rain, snow, sleet, especially. Well, we'll leave it there. What do you got on leading edge erosion?
Leading edge erosion is the effect where water particles or ice particles are actually hitting the plastic edges of wind turbine blades and creating this pitting damage. You see the same thing on aircraft, helicopter blades, same thing. But in the wind turbine case, it tends to be mostly rain, sometimes snow, sometimes ice. And as those little tiny particles hit the blade surface, there's like a shock wave. If you think about, it's hard to conceive a little droplet of water doing any real damage, but you hit it hard enough and if enough speed, it creates a shock wave in the blade itself, especially on the surfaces where these coatings are. And it wants to try to rip the coating off or to shear the coating off, and one water droplet won't do it. It's going to take millions and millions of water droplets. Well, if you're out in the ocean, you're in some place that rains a lot, it doesn't take long for that blade to impact millions of water droplets. And so the accumulation over time starts to happen. You get this very odd shaped pitting happening onto the blade. Now, it's just like having a wound on your skin. Once you get past the outer skin layer, you're down into things that matter. You're getting into the structure of a wind turbine blade, and you're shoving water inside of it, and that does even more damage once the water gets inside, and the freeze and thaw that can occur on a lot of places on the planet where it's cold in the wintertime. You get water inside of a structure, and you let it freeze, and it expands. It tends to rip apart everything it gets into. So leading edge erosion, rain erosion, one obviously impacts the aerodynamics. It makes it less efficient for that blade to spin. But the subsequent is it starts to affect the structure, and if you get water into the structure and the freeze thaw of that, now you can really be destroying a wind turbine blade, and it's almost invisible in a sense because from the outside on the blade, it doesn't look like that much has happened on the outside, but on the inside, if it's full of water, now you have a really big problem you got to go solve.
So what's the typical time where you start to see problems? Obviously, it varies a lot depending on the climate and all that stuff.
Yeah, it's related to climate, related to the speed of the turbine blade. It's related to the coatings that they put on the turbine blade, whether they've actually done any testing or not. Like LM Glass Fiber and now GE have built a rain erosion test facility over in Denmark to check that out, and so they're looking at it closely. There are a number of rain erosion test facilities in the world. Dayton, Ohio, there's one. Over in Ireland, in Limerick, Ireland, there's a smaller setup. So there's a couple of setups around the world that people go to. But if they haven't done any testing, then it's just really you're guessing at it, and it's like the worst possible way to do anything engineering-wise, particularly for something that's going to be out in the atmosphere for 20-plus years.
And what do these test facilities look like? I assume they're not just creating rain and swinging things through it. I'm sure they're just blasting water, like using a high-pressure nozzle and just blasting stuff, or how does it work?
No, it was your first guess, actually.
Really? That seems like a huge pain. I mean, that seems like the most accurate, but that seems like a huge pain.
Yeah, they think of it like a grain silo. If you're, I'm sorry, I'm from the Midwest, but if you ever seen a grain silo, it's this round cylindrical building, right? What you do is you make a round cylindrical building, and then you make these rings of syringes, and you hook those up to water. So you got these a couple hundred syringes hanging from the ceiling, essentially. And then you can...
Sounds like a horror movie, but go on.
Yeah, it's a little scary to walk into, quite honestly. I don't like being around needles, and that's a place there's a lot of needles. So, and then they take an electric motor on the floor with a looks like a helicopter blade on it, something similar to that. And it's we call a whirling arm. And then you put your samples on this whirling arm, and you spin it, so it's spinning horizontally. And then you turn on the water, and the water droplets fall, and the water droplets have to be a certain size, and it's all at a certain rate. Usually it's an inch per hour or 2 inches per hour or something like that. And they just impact it like it would be, supposedly like it's supposed to be in the natural environment. But the kicker to that system is when you start spinning something in a cylindrical tower, it creates its own aerodynamics. And so the water droplets always don't fall as perfectly as maybe they should. And so every setup I've been to or seen has its own particular characteristics. No two facilities are the same, and no two facilities will give you the same result. It's really an apples to, you have to run one sample and run it against another sample and see what the differences are. There is no absolute, and there is no known, the engineering world will tell you there's a known standard for that. I say that is not true. Based on everything I've seen, there is no known standard for rain erosion. Every part of the world has their own unique characteristic. You're just going to have to go test it. Yeah. The only ones that I think have done a very interesting or unique setup is over in Limerick, Ireland, the University of Limerick, where they have a smaller cylinder. It has a rotating arm on it, and it's needles, but there's a circle of needles, not a plethora of needles. This is like a circle of needles, and they time the water. They have each of those needles on a little water valve that's timed so that the water droplet that comes out the needle impacts the sample every time. So they time it so the water droplet hits the sample. It's not random. So they actually spin this thing and they time these water droplets. That I think that provides a lot more consistency to the result. That hasn't been implemented everywhere. I've only seen that setup over in Ireland. But I like that setup, one, because it's compact. I didn't have to build the whole building, and two, it's going to give you very consistent results.
So it's spinning you said like a helicopter blade.
Yep.
So horizontally.
Yep.
I mean, isn't that going to sort of push air up towards the falling rain and like give a buffer, like kind of like soften its blow to it? I feel like, and of course with a wind turbine, that's it's perpendicular to the axis it'd be spinning in real life.
Right.
Is that problematic or no?
That's a great question. I don't know if there's any good answer to that. The aerodynamics, and I've never seen anybody do modeling of the aerodynamics of a rain erosion facility to see what actually is going on there.
People got other stuff to do. They're busy.
Well,
yeah, they're riding their horses and their electric lawnmowers. Yeah.
Yeah, they may be doing that, but the way it's let's just talk just basic engineering right now. If you don't know what's going on in the real world, you try to simulate the best you can. And how do you do that? Well, you got to limit a pot of money, and with that pot of money, what can you do with that pot of money? That's what happened. and Dayton, Ohio is where the Air Force Research Lab always was. I think they transferred ownership of that rain erosion facility to the University of Dayton, I think. I think B.F. Goodrich also has one out there similarly. But it's sort of a brute force. Whatever we can mock up in the lab, we can then build a structure and just test it. And then there's no absolutes here. It's definitely A to B to C testing. And that's what you go with.
Gotcha. That's interesting. Yeah, and that makes sense because, like you said, A, we need facilities, and B, they're never going to be exactly the same. They're going to be like a snowflake, and C, it's not going to perfectly replicate the environment.
Nope.
That's a really interesting thing because we think of all these, you see like these tests of consumer products where they have like this mechanical system. It's like punching the car seat, 50,000 times to like see how well the car seat wears, and you're like, okay. That's really interesting, but none of these are ever going to completely replicate the actual environment of a human putting their fat butt down the car seat 30,000 times between, in 10 years. So that's interesting that, you couldn't just necessarily compare it from one facility to the next and expect. You just have to go, all right, let's get all samples to this one facility and all, go to some other facility.
Yeah, and they've done some what they call round robin testing. So you take the same samples, you run it to different facilities. They do the same thing in the lightning world too. Same thing. And I will tell you, having been to a lot of lightning facilities, you're not getting the same result. Even though you think you have locked this thing in and you have specifications, especially on the aerospace side. You got specifications that say they should get similar results. Nope. You're going to get. They're not going to be identical. I mean, they're going to be generally the same. But that's as most you can hope for. Yeah.
Well, American Lightning doesn't exercise as much. They eat a lot more fatty foods, so those lightning bolts are way different. If you get a Japanese lightning bolt, they have a lot more greens in their diet, a lot healthier.
Way healthier,
yeah. Mediterranean light bolts. I mean, great life expectancy. Yeah, it's important stuff.
I think that obviously, having grown up in the United States, particularly the era that we grew up in, a lot of things are sort of Americanized standard because you don't have to go outside of America to get pretty much anything you want, right? And so you sort of things kind of get homegrown, and you assume everything in the world is just like that. That is the furthest thing from the case. The environment in America is way different than the environment in Europe in a lot of cases. It's totally different than the environment in South America. You just can't assume one size fits all. That's a classic engineering mistake. It's just like if you bought a car, Dan. I mean, would you buy a Japanese car like that? In a sense, like the Japanese car is going to be different than an American car. It's going to have different performance because, and I'll give you a good example. When I used to buy Hondas early on, I didn't think they performed very well in really cold weather. Now that's changed. That's changed a lot. And I'll give you even a better example. So Honda cars in Canada came with extra features because it's so dang cold up there that I couldn't buy. We're probably maybe 2.5 hours from the border of Canada, so it's cold here. We couldn't buy those same things, right? So every different part of the world is a different environment.
And that makes sense. I mean, just like the formulation of Coca-Cola is different all over.
It is, right?
People's tastes change, but to your point, it's more like the testing. Like maybe if a car company was born in South America, where they just don't have cold weather days to really test like what it's like driving a car in Winnipeg. Then maybe it's just fundamentally different. Like they're not as good at making a cold weather car there.
Right.
Seems reasonable.
Right. So we're doing the same thing in wind turbines, right? We're figuring out there's different climates and there's different particularly the lightning side. There's different levels of lightning. The lightning responds differently in different parts of the world. We shouldn't be surprised by that. We are all the time surprised by it, but we shouldn't be surprised by it because we should have known that from other things we've already done.
Yeah, gotcha. All right, well, that's going to do it for today's episode of Uptime. Alan, thanks again for another great show. And for all of you out there, thank you for listening. Be sure to subscribe on Spotify, iTunes, also here on YouTube with full video clips and short little bites. So if you're interested in just jumping in for a quick topical episode on our YouTube channel, we have tons of those. So thanks for being here. Be sure to leave a review on iTunes and check out our website at weatherguardwind.com, where you'll find more about WeatherGuard Lightning Tech's products, our lightning protection systems, and ways we can help you keep your wind turbines running. Thanks for being here again, and we will see you next week.